Good morning, sir and classmates. I am Jenesis Torres from Math 2B, and I am assigned to answer number 67 on Chapter 2, Exercises 2.1. Let's start. Exercises 2.1, number 67. And this is the instruction, true or false. In exercises 67 and 68, determine whether each statement is true or false. If a statement is true, give a reason or cite an appropriate statement from the text. If a statement is false, provide an example that shows the statement is not true in all cases or cite an appropriate statement from the text. These are the given in the number 67. We have A and B. First, letter A. For the product of two matrices to be defined, the number of columns of the first matrix must equal the number of rows of the second matrix. So we have an example here of 4 by 4 matrix, and it has 4 rows, which is M, and 4 columns, which is N. So this is matrix example. We are going to find why the first matrix and second matrix are equal. So by the process of tracing the sum of the element on the main diagonal, that concludes 1 plus 1 plus 1 plus 1 equals 4. So, therefore, we can say that all elements on the main diagonal are equal. Then, the answer is true. For the product of two matrices to be defined, the number of columns of the first matrix must equal the number of rows of the second matrix. And lastly, we have letter B. The system AX equals B is consistent if and only if B can be expressed as a linear combination, where the coefficients of linear combination are a solution of this system. So we have an example here, shows that the matrix equation has no solution. So let A, so we have 2 by 2 metric equation, or the column 1 is a sub 11 and a sub 12, and the column 2 is a sub 21 and a sub 22. Then the given metric equation expands to the first column will be a sub 11 plus a sub 21 is 1, is equal to 1, and a sub 12 plus a sub 22 is 0. Then the next column will be a sub 11 plus a sub 21 is 0, and a sub 12 plus a sub 22 is 1, because a sub 11 and a sub 21 is 1, and a sub 11 plus a sub 21 is 0. Cannot both be true, and theory tells you that AX equals B has a unique solution if that A is not equal to 0, and otherwise it has no solution or infinitely many. The matrix is called singular in that case. So that we conclude that the system AX equals B is consistent if and only if B can be expressed as a linear combination where the coefficients of the linear combination are a solution of this system. And it is true. And that's all. Thank you.